Hello, everybody. I'm Kim Arcand, and I'm going to be talking today about our accessible universe through sight, sound, and touch. So I work for NASA's Chandrasekhar Observatory, which is operated for the Center for Astrophysics for NASA. And I've been there for about 23, 24 years. And I spent most of my career working on these digital assets from the telescope, which goes about a third of the way to the moon. And you can see on my slide here, I have the very first image that we ever released from Chandra called Cassiopeia A. It's a beautiful supernova remnant. But those first years of working on these digital assets, I was really concentrated on the visual. And it came to me, about 10 years ago that I really needed to do some work to think beyond just prioritizing the human sense of sight. So that brought me to work with some collaborators who had been taking this data of Cassiopeia A, this beautiful supernova remnant, and plotting it into 3D. And from there, I actually worked with the Smithsonian 3D office to be able to take that and learn how to 3D print it. And that sort of procedure, that process, that journey just really opened up my eyes to a new way of being able to both understand and also present scientific data in new ways that don't just prioritize sight. So after that first model, that first 3D printable object of NASA data, it was really important for me to be able to find more data and then to be able to work with people in the community of people who are blind or low vision to be able to figure out how this 3D printing could be optimized for them. And there are a number of sort of parameters on the size, the resolution, the quality, the access points, the quantity, and sort of that universal design aspect that became really important to making those 3D models more usable, more accessible, and have better meaning making for people who are either blind or low vision. We have a paper on all of the details. So if you're into 3D printing, please feel free to grab a copy of this slide, or I can for sure share the paper and talk about that with you in more detail. But essentially, we found that overall, these 3D models were really, really helpful. And it just helped address that issue of equity and accessibility in this idea of being able to share knowledge of our universe. We created 3D printable kits of various objects that were stars or various stages of stellar evolution, and worked with a number of different community members to make sure we really pilot tested them and formative tested them very, very well. Working with a number of groups such as the International Astronomical Union, various NASA centers, and groups of either blind or low vision people. And we were really, really happy with that project, but then the pandemic hit and we just sort of realized we needed to pivot. So one of the ways we were really working on pivoting was sticking in a digital space. And we've worked again with the 3D office at the Smithsonian to be able to really get some extra bang for the buck out of our 3D models. We worked with them to incorporate them into their 3D Voyager library. And so they're operable in augmented reality as well. But then we also started concentrating on this idea of sonifying the data as well, or translating that image information into sound. So data sonification is a real growing area of research for astronomy. Both on the research side, but also on the discovery side and communication side. And feel free to grab any of the URLs. We can put some in the chat as well if you want to learn a little bit more about this project. But I would just like to play a little snippet of two pieces so you can get a sense of the type of sonifications that I'm talking about. These are sort of bespoke creations that translate the various image data into sounds that hopefully are pleasing. And so this first piece I'm going to play a short piece of the area around the supermassive black hole at the very central region of our Milky Way galaxy. This object is called Sagittarius A star, and it's sort of like the downtown area of our Milky Way. And we're going to listen to 3 different telescopes, with each being assigned to a different kind of sound as they sort of play together into this little symphony of an area of a black hole. And you'll hear as we approach the bright white blob on the lower right side, that symphony sort of starts to crescendo as we get closer and closer to that activity. And the second piece I'll play is the Chandra Deep Field South. Now, this image perhaps doesn't look super exciting or super spacey. It's kind of like a black rectangle with a bunch of multicolored confetti tossed onto it. But it's actually a really interesting field scientifically because it's essentially a spot in the universe that we observed for a long time where we found thousands of black holes. And so we've taken these images of black holes, all these little tiny dots, and we've assigned them to different kinds of sound based on their energy from low to high. And so what sort of looks perhaps like not the most exciting thing, I think actually sounds quite beautiful. So here we go. This scans from the bottom to the top. So I'll stop there, but that's just a little snippet of all those black holes and the different kinds of energies that we can hear from them. So this project that we started in 2020 actually went completely viral, which was a very big surprise for me. We had over 1.5 million listens on NASA's SoundCloud within the first week and a half. Very significant news coverage, very high levels of engagement on social media, across YouTube channels, etc. It was the most popular feature on the Chandra website for 2020 and for a pretty good chunk of 2021. We conducted a research study to be able to follow up on this and how people were sort of looking at these different pieces and understanding them, or I should say listening to them and understanding them. And we had over 4,500 responses, which included one person who noted that it was the most fun survey I ever took, which was definitely a compliment. And we found that overall, there was really high learning and enjoyment levels, both for people who were sighted or for people who were blind or low vision. And then also, surprisingly, that learning about how others access information, about our universe, there was a really significant check of that box as well for people who are sighted. And that I think was also a really nice thing to see. So a lot of emotional responses were recorded from listening to these pieces, from feeling peaceful or feeling relaxed to feeling calm or feeling curious. And I think that was definitely helpful to see and understand, particularly during the pandemic. And perhaps that was part of such the huge response to it. But there was still one piece missing to our sort of digital accessibility package, if you will. And that was that astronomy is such a visual field. And we had sonifications of some of these images, and we had 3D prints of data sets that we could create 3D models from, but there was still a wealth of data that we did not have that accessibility component for. And so we partnered with some colleagues of mine, JJ Hunt and Christine Malek, to be able to create sort of bespoke visual descriptions of every single Chandra image that's been released since January of 2021. So as it's released in real time to the public, we provide a detailed visual description of what that image is showing. And we use that information into like text and audio formats. They are linked into a podcast so people can listen to them. We also use all that information as alternative text on our website, as metadata, as alt text on social media, etc. I won't go into the details of the technique, but we also have a paper on this. So if you'd like to learn more, I'd be happy to share that with you. But essentially there are two key things. And one is that it was really important to combine that scientific information with the visual description. They had to be integrated in a sort of strategic way. And two, the sort of grammar of it, if you will, we had to have numerous commas, make sure we're using the proper full nouns and not just saying things like it or the, and really being specific with our language, paying attention to our sentence structure. And all that helps when people are sort of building their mental map of an image, particularly if they're using screen readers and the cadence that the screen readers will read at. So we've been really happy to work on this project as well. I've got just an example on the screen on the Cat's Eye Nebula that I'll just read a short snippet from. But the idea is to be very descriptive with this text and creative with how we describe it. And so there's one sentence I thought you all might like that says, "The dust cloud resembles a translucent pastry pulled to golden yellow points near our upper right and lower left, with a blob of bright purple jelly inside the bulbous pale blue core. So there's this idea that taking an abstract or somewhat esoteric seeming image and being able to relate it back to things that people might be a little more familiar with has been a really helpful technique and also rather fun to work with. So this overall project has really been helping us inform not only what we're doing with our metadata, but also really how we approach and apply things to our other scientific writing for Chandra as well. And I'll just say, as I sum up, that, for me, we're sort of designing the universe here. We're taking all of this information from those ones and zeros, that original binary code, and ramping it up into something like a data set. It doesn't have to be an image. It can be a sound. It can be something you touch. It's just this idea that the availability of data, just putting it out there, it does not equal an accessibility or an equity of access to that data. And so we're trying to pay particular attention to that. So I'll just sum up by saying thank you all for being here, and a huge thanks to all of our teams that have been working on these projects with me, our visual description team, our Sonification team, and our various 3D, spatial, and haptic teams as well. And yes, I look forward to any questions you might have. Thank you so much. Hello, I really hope you've enjoyed the presentation so far, and I'm going to go to our first question. So the question is, have you had any community feedback on the visual description program? And we actually have done quite a bit of testing on this. We work with people who are in the blind or low vision community to create them. And then we have done a number of programs with the community members to make sure the meaning making, the processing of that information and the reception of that information is really on par. And so far the feedback has been very positive. There's been some very helpful feedback about like the length of the captions, for example, and how much information to include. And then there's also been very lovely feedback where people are saying things like, this adds the aesthetics back into visual descriptions, or this reminds me of how announcers used to be able to describe things, pre-TV days when it was more radio and you had that idea of sound being able to convey messages exclusively. That they want to see more of this throughout other scientific missions, asking, what other groups are trying these things, and have you been able to help others learn how to do this? So lots of really fantastic feedback, lots of really great questions, and lots of support to keep doing this thing. But I think for me, the sort of, the really lovely thing about it has been that it's this idea of being able to provide context in new ways, because every time we do one of these projects that we're trying to improve accessibility on our universe of data, I just find over and over again that every time we're trying to make it accessible to someone, we end up making it more accessible for most everyone. And that's a really pleasant feeling to have when we're working on these projects. So I hope that answers your question. And the second question is, are there guidelines for writing the picture descriptions? And yes, there are some really good guidelines, I hope. We started working with someone who was already a professional image describer. So using his knowledge base was really helpful. And again, working with our partners who are in the blind and low vision communities to be able to make sure that material makes sense. So working closely with Christine and JJ, as I mentioned earlier in the talk, has been really pivotal. But because of all of the specific techniques that we had to sort of refine for our own data here at the Chandrax Observatory, we've definitely picked up quite a few tips and tricks along the way. So I think I mentioned we have a paper on that. If anybody would like to learn a little bit more about those tips and tricks after, please do feel free to email me. It should be on the contact slide, and I can also pop it hopefully in the chat. And yeah, essentially the summary is the sort of really two key things. One is just like that style and tone that I mentioned briefly. And two, the idea of really making sure you're integrating both the science and the visual description, because it was very clear that trying to separate off those two as distinct pieces did not work, including just one and not the other did not work. If you're going to be talking about esoteric concepts like black holes and pulsars and quasars and magnetars, some of those concepts really need to be described before you can start to get into the visual. So having that understanding that the context of the science cannot be separated from the real context of the visual was a very important key for this work to be successful. So I hope that answers that question. And again, happy to provide our sort of cheat sheet, if you will, on tips and tricks if you want to try this in your own program. The next question is, what are you working on next for the Sonification program? So the Sonification program has been just very rewarding overall because of the overall user response. I mentioned when I was talking earlier that I was very surprised at the huge number of people who are cited that really took a lot of enjoyment from these materials. And also when we were working on this material with community members who are blind or low vision, for example, being able to understand how they were receiving this information, how they were perceiving this information was really helpful as well. My colleague Christine, for example, who had listened to some of the Sonifications before they were released, just had this wonderful phrase that she said that, you know, for her, and she's been blind since birth, for her, these Sonifications, they're kind of like the main meal. Whereas for someone who's sighted, the Sonification can kind of be like the dessert. Both are very valid ways of eating, but you know, that nutritional value that's coming from the main meal is really key. And so having something like that that is useful for people who are blind or low vision is fantastic. And then having something that can also add value to someone who's sighted or has different learning needs or is neurodiverse, for example, is also really quite rewarding. So we've been releasing like little mini albums, I call them, like 3 or so Sonifications at a time as we create these sort of bespoke manifestations of the data through soundscaping. And we've done, I think, about 12 so far. And we have some new ones coming out pretty soon, very soon, actually. So please do stay tuned for that. And I think what some of the fun has been with this project is the research component on figuring out exactly what kind of pieces work. We've tried all different kinds of techniques from left to right panning, bottom to top panning, different kinds of sounds, different kinds of tones, data that is static, data that is changing, different kinds of, you know, surveys of data, so larger collections of data, thematic approaches to information. And it's been, I think, really exciting to see which kinds of those combinations of sound and data expression really do work. And that work is going to be continuing as well. So I'm very excited to see if other, you know, types of programs, other scientific missions, other different types of data find success in this area as well. So I really hope to both explore the research side and also the sort of communication side of things. And the next question is, how do you prioritize meaning versus listenability in sonification? That is an excellent question as well. And I really think that there is like a bit of a puzzle. We have to fit together those pieces to be able to make sure that it works. And we do a fair bit of user testing with our sonification. So I'll work with System Sounds, which is the group that we work with to do this bespoke sonifications. So Matt Russo and Ender Santaguida specifically, as well as other colleagues, to collect the data that's going to be used, kind of figure out what the scientific story is to tell, and then sketch out a picture, if you will, a sort of audio picture of what that data might be best approached and how it might best sound. And then it's a very, like, you know, particular combination of coding and then sound engineering to be able to come up with a final product. And there's a lot of fine tuning, both as that's happening and then in that final stage of the sound engineering, sure that it works, as well as the user testing as we're going through it. So being able to to find that sort of really nice interlocking connection of the sound that describes the science in an aesthetic way, and the sound approach that is really bringing the story of the science together, can be very tricky. And of course, like visuals, like the image behind me, for example, these things are things that are created. So the people working on them are making choices, and doing things to create this product, if you will, from something that cannot be seen naturally with human vision into something that can be essentially heard. So it really is a test of, trying to figure out what works best. And there's a lot of trial and error in there. There's no real codification yet, at least, for how we're approaching these sonifications. They're very much unique creations. So I hope that helps. But really, I'd say, to sum it up from my long answer, testing is the key. And then there is one more question here on that issue. Are the rules of the music orchestration consistent throughout, so users can begin to differentiate and make sense of the images when they can't see the images? So I think the question there is, yes, they are consistent throughout a piece, but we so far have found that, and this is something that happens in the visuals as well, whenever I'm working on just like a static two-dimensional image, for example, the image behind me, which is this beautiful planetary nebula, for example, a potential glimpse of what our sun could look like in, say, 4 or 5 billion years. All of this data that we're taking and sort of concatenating together and applying colors and different kinds of smoothing and really making sure the data works to tell the story of what that future of our sun might look like. There's no real standards. There's no real, black and white codification of what rules to apply to create an image. And so far, we found similarly with the sonification, when we're creating these experiences, we really make sure the scientific story and the data that we're presenting, those two sort of threaded things, are driving the production of the sonification. So it is very specific to the storytelling, if you will, of the data that we're considering. And so having a sort of, standardized approach has really not worked for us so far. That's not to say that it might not be something that we do in the future. But as far as this soundscaping project is concerned, having, unique sounds for each one is really because it's all about making sure that that scientific story shines through in the most authentic way possible. I can say, however, that we have other projects that are ongoing. I work with a very talented team of computer science students at Brown University, for example, and we're working on a project to do simple sonifications and even haptifications, which is using like the vibrational response from, say, your phone or a tablet device to be able to explore images through that way. So it takes a very sort of codified response, approaching the data just left to right in most cases, or if it's through like a smartphone or a smart tablet, being able to use the input of the user and having very simple sounds to let you know when you're inside the range of the image and then what different aspects of the image are sort of expressing. But it's very, very simple sound wise. It's more of like, a beeps and boops kind of thing, and is specific to just providing a near real time sonification of that data for any image anywhere, essentially. So that project is ongoing and we hope to have a beta of it released pretty soon. So I have a tendency to do long answers, but I hope that helped that question. And it looks like I've got one more question as well, which is, have you seen any new research impacted by or citing the sonification program yet? So I'm assuming that means research of the program that I'm working on. And so far, I haven't seen research on it specifically. I'm still working on the manuscript of the paper that evaluates and analyzes all of the data from our survey. So far, that is still in progress, and it's like almost a year later. So I'm trying to bust a move a bit on that paper. But I feel like until that paper is published, peer reviewed and published, then the citing will not be quite so often. However, I have absolutely seen our materials included in other, sort of like more anecdotal ways in other programs and in other like more, casual manuscripts, I guess I would say. And that has been gratifying to see. This is, as I mentioned, a growing area of research. We are certainly not the only ones taking this approach. We're certainly not the only ones doing these things. So I think as the field grows, that sort of professionalization and give and take will continue to grow as well. And the last question is, can the cheat sheet you mentioned be provided? Absolutely. I can provide a link in the chat as soon as I'm done speaking, because I can't talk and type at the same time, apparently. And if you do find that useful, please let me know. And if you have any questions on the tips and the tricks, again, I'd be really happy to answer questions on that more specifically. So I hope that helps. It's a really fun project to work on. It's been, I think, very rewarding to have this type of mission and this type of data to be able to work on and create these new accessible products. And yep, it's been just great to have a whole new universe to discover. So I hope everybody enjoyed this presentation. Thank you.